explain to you first of all what we will cover in this class. So first of all, we will cover electric field. So these are objectives for this class. We will cover electric field. Then we will go to capacitance. Then also we will talk about charge distribution. So, and there are some points you need to understand about charge distribution. So these things we will cover in today's class, and also we will do some questions from past papers. Okay, so let's get started, and let me clean this one so we can write more on this. Okay, here. So the first thing, please, we need to understand, we will start from very basics and then we will just build up and we will continue. So the first thing we need to understand about electricity is that means the charges. We are talking about static electricity. So we need to understand if we have a positive charge, so we draw lines pointing away. So why we draw pointing away? The reason is that if we place if we place a positive charge, for example, the force on this one is pointing away from this charge. So we draw this outside. And next thing we also need to understand, if we have a negative charge, for example, so we draw these lines, the electric field actually, we draw these lines pointing inwards. So why pointing inwards? The reason is again same. If we have a positive charge, for example, if we place here the force on this positive charge, the point charge, we often call this one positive point charge, or simply we call is a point charge. Okay, sometimes we also call this one test charge. So the force will be pointing this way, so we draw like this. So and also now the next thing we need to understand is that, so here we are talking about point charges. So here I'm talking about point charges. So how we can find electric field of point charge? For example, if we need to find electric field at this point, simply what we need to do is we will do K times capital Q over R. Let's say this distance from here to here, this is equal to R. And this Q actually, this is source charge. Means this charge is capital Q. So we can find its electric field at this point. So simply we can calculate with this one. So this is KQ over R square we can calculate. Now, if we need to find the potential, for example, at any point, let's say we need to find the potential here, and this distance, this is a point charge, so it has no side. So let's say this distance is equal to R1. We need to find what is value of V1, means what is potential. So here this is electric field. So this is electric field. So we are here, this is electric field. And also the K actually, this is equal to 1 over 4 pi epsilon naught. And the value of K is approximately equal to 9 times 10 to 9. So this is equal to Newton meter square per Coulomb square. So this is how we can find out. So also you need to understand is that this is a constant actually. This is a constant. And what is name of this constant? We call this is permittivity of free space. Permittivity of free space. So first let me finish electric field, then I will go to potential. So this is permittivity of free space. So this one tells us how easy it is. So it tells us how easy it is for an electric field to pass through any medium. Pass through any medium. Okay, so pass through any medium. So this value, so for different material, this is different actually. Okay, so permittivity. So now you need to understand this K actually, we are talking about air actually or vacuum. So this number is for air or vacuum. But if there is any other material, this number will be different. So you have to understand, if I have here k is equal to 4 pi over epsilon naught, so if epsilon value, for example, this increase, so this will decrease. So you have to be clear about this one. So the next thing we need to understand is that if we need to find a potential, how we can find potential, as I said before, we need to find V1. So simply potential we can find out, that is KQ over R. Again, Q is the source charge here. So this is Q is the source charge, means this one here, the big charge here. So we can calculate. And this is for point charges. Now, the next thing we need to understand is that if we have, for example, uniform electric field, I will write down here for uniform electric field. So how we can calculate E for uniform field? So we are talking about electric field. It means this is uniform electric field. So let's say we have these two plates. You can see here, let's say one plate is positive. So this is positively charged, and we have another plate. Let's say this one is negatively charged. So the electric field between these two plates, if we need to draw, so we will draw these lines, and these lines has to be evenly spaced, means the distance between them has to be the same. So we call evenly spaced. So then we call this this electric field is uniform. So the lines has to be evenly spaced, means the distance between lines has to be the same and parallel. So this is second condition, is also parallel. Okay, so but one thing we ignore in this case is that at the edges, actually the lines will be like curve, actually like this. So you can see will be like this. So we call fringe effect. So we call fringe effect, means the field is not uniform at the edges. So we ignore, actually most of the time we ignore this one. So the rest of the field is uniform field. So now if, for example, we have, let's say, the distance between these two plates, let's say distance is equal to D, and let's say this plate is at 0 volt and this plate is at V volt. So how we can find the electric field between these two? So we will say how we can calculate electric field. So we call electric field. Okay, so we often use E, capital E for this one. So we have to find the potential difference between two plates divided by the distance between plates. So we will just divide by D here. So in this case, if I say what is unit of electric field, so unit will be simply volt per meter, or you can simply say volt per meter. But here you see electric field we have here, actually. So this electric field we can also write down. F, for example, in terms of force, we can also write down F is equal to E times Q. The charge means you place inside electric field. So this one E, we can also say that E is equal to F over Q. F over Q. Q, what I'm saying is here, so let me little bit more be specific about that. If this is capital Q, actually, the small q we are talking about the test charge. Let's say this is plus small q. So here what you have to multiply is, it has to be the test and other charge you bring inside. So I will write down this is test charge, so divided by q test. So you have to be little clear about these points. Sometimes maybe you get confused, so you have to be clear. This is q test and this is q source, means this charge is producing electric field. So we can calculate. So in this case, the unit of electric field, sometimes in physics board they will ask you about unit. So if we derive the unit of electric field from here, we will say this is Newton per coulomb, or simply you can write down like this. So you can say electric field has two units here. We can say is Newton per coulomb, or we can say is volt per meter. So we have to be clear about this one. So sometimes they can ask you the units. So these are two units for electric field. Okay. So this is how we can find the electric field if it is uniform, and this is how we can find electric field if this is a point charge. So this is how we can find the potential for point charges. So this all is about point charges, mean these two columns you can see I'm just talking about point charges here. Okay. Now one thing more we need to understand about this field is that, as I said, uniform. So what exactly it means when I said uniform? One way you can understand is that the lines are evenly spaced, but uniform electric field means that, so uniform electric field is telling us that at any point inside this field, E is the same. At any point, E is same. E is same. But force is not same. So you have to be clear about this one, that at any point inside this field, E is same. So that's the reason we call this is uniform electric field. So what it means is that, let's say I have charge plus here. Plus means one charge I have here. If I place here the force on this one, let's say is equal to F. I just for simplicity say is 1 Newton. But if I place this charge here at this point, the force on this one again will be 1 Newton if this is same charge. But now let's say I have another charge here. The charge on this one is 2. So the force on this one will be 2 Newtons because the charge is double. So you can see from here, if this one is double, this one is double. So this formula is true for uniform, is also true for point charges. So you can see here, if I double this one, this will be double because this one is same. So I will just say this is same. If I multiply this by 2, this also has to be multiplied by 2. So this is we need to understand. Means E is same but force is not same. As you can see here, force here is double. If the charge will change, force will also change, but E will stay same. So this is what we need to understand. So here just few points I didn't write. So let me write down those formula for you. So one is that the Coulomb's law. Some student maybe they didn't studied this one. So let me write down for them. Coulomb's law simply tells us that F is equal to, if you have two charges, for example, let's say we have charge 1, this is Q1, and we have another charge, let's say this is Q2, and they are apart by, means that separation between these two charges, let's say, is equal to D. So how we can find the force between these two charges? So the force we can find out by this formula. This is K Q1 and this is Q2 over distance square. So this is how we can find. But also sometimes they will ask you, is the force on Q1 and Q2 is the same or not? So you have to be very clear about this one. Let's say if this force F1, just for simplicity, let's say this is equal to 1 Newton. So the force on this one also has to be 1 Newton. Equal in magnitude but opposite in direction. So it has to be also 1 Newtons. Okay, so 1 Newton and 1 Newton. So this is we need to understand. Okay, so there are few points, but there is a lot more to discuss about this field. So I will clean this one. If this is clear to you, so I will clean and I will write down more points for you. Okay, so if you want to take notes, you can take the screenshot of this one. So that's enough. So I will clean and I will go to next one. So let me clean this part first. Okay, so here. Okay, other here. So these points. Okay. Okay, now please, we need to understand more about this one. I will write down here for uniform electric field again, because there are a lot of points we need to understand about uniform electric field. So here I'm writing for uniform field, means uniform electric field. So we need to understand, if this is our uniform field, I will just redraw this one. I will just draw two lines here. So this is our uniform electric field. Now, if we place a positive charge here, this plate is V plus and this is 0 V. If I place positive charge here, for example, we will simply say it will go in direction of electric field. And if I place a negative charge here, you will simply say it will go in direction opposite to the electric field. So this you have to be quite clear about this one. This is very simple thing, but it is very important to understand. This one means this is the negative plate, and this one what I'm saying is that this is positive plate. For simplicity, I just say 0 volt. So this is negative and this is positive plate. And one more thing you need to understand about this one is, let's say if this charge is here, the positive charge is here, for example, if I place here, the electrical potential energy for this one will be maximum. Maximum electrical potential energy when you place this positive charge next to positive plate. But how about for negative? For negative charge, electrical potential energy will be maximum when it is placed next to negative plate. So we will say here this will be maximum. And but when it is here at this point, the positive charge, so the electrical potential energy at this point has to be 0 here. So for this one electrical potential energy, we will simply say a minimum or 0. You can say I will just say it will be minimum at this point. So the better way we can simply say it will be minimum at this point. So we will say here it will be minimum for positive, here it will be minimum for negative. So you have to be very clear about this one. This is quite simple point, but I have seen many questions in physics board. They will ask you about this concept in different ways actually. Now let's say if I place here now, let's say I place positive charge here, and I also place a negative charge here at this point now. So my question for you is that, let's say this point is point 1. This positive and this negative charge, do they have the same potential energy or not? So here the question for you is that, same EPE, electrical potential energy, let's say at 1, do they have same or not? At this point, you see, so you will simply say that not same. So you will simply say not. Excellent. So you will simply same. So you will say not, because it is not same. Now again, let me ask you one thing more about this one. Let's say at 1, force, is the force on here, I will say, is the force on positive charge and is the force on negative charge is the same or not? If I ask you at this point 1, so you will simply say that if Q is the same, this is plus 1, this is minus 1, so you will simply say otherwise same. Excellent. So you will say if this is 1 coulomb and this is minus 1 coulomb, so it has to be same. So these are the points we have to be clear like this about these points. Now one more thing, let me ask you, if I ask you another question about this one, so is the electric field, now we need to understand, is the electric field at point 1, I was talking about 1, is this electric field, is this same or not? Is it same for plus Q? I mean, is it same for plus plus q, and is it same for minus, is it same for minus charge, let's say 1 coulomb. So you will say that electric field is not depending on these charges, so electric field is same at 1. It doesn't matter I place any amount of charge, is it positive, negative, electric field will be same, because this electric field, how we find, that is equal to delta V over D, so it will not change. So we have to be very clear about this one. Okay, so these things we have to understand about this. Okay, now, okay, I will clean second column now, and I will write some more points for you. So here, so let's say I clean this one, and this column I will write down. Okay, now, so we have to also, we need to understand again about electric field. There are a few more points we have to understand. There can be a lot of question about this kind of fields actually. So let's say we have again here, so this is uniform. This plate is negative. So this is negative, I will just draw two lines here, so to keep it clean and easy to understand. Now, if I have, for example, I have one positive charge here at this point, as I explained to you before, when the charge is placed, the positive charge is placed next to positive plate, electrical potential energy is maximum. So how we calculate this electrical energy? So we call electrical potential energy. So what I'm saying is that EPE is electrical potential energy. So I will just write down here for you. So maybe some student not clear what is EPE. So this is electrical potential energy. So this is how we can write down. So how we calculate? Sometimes we use symbol for this one, capital Q, capital U actually. So this is electrical potential energy. So we calculate Q times delta U. So this is Q times delta U. So delta, this is U is equal to Q times delta V. Delta V means that this is the potential between two plates. Okay, if it is just placed next to this one. So we can calculate this one by Q times delta V, and Q is the charge we placed inside this electric field. So this is how we can calculate. Now, one question they can ask you is that sometimes they will ask you when the charge reach this plate. So can you figure out its velocity, means its speed? You need to calculate. So simply we can calculate. If I ask you, you need to find the speed, and if I give you the mass of this one, so we can figure out. So how we will figure out? By conservation of energy, simply we can figure out. So we can figure out by conservation of energy, simply we can use. So when charge is here, it has electrical potential energy. When the charge will reach at this point, so we can calculate its kinetic energy. So we will simply say Q times delta V has to be equal to, by conservation of energy, is equal to gain in kinetic energy or change in kinetic energy. If we say at this point, so let me be a little bit more specific about what I'm saying is that, so this is equal to gain in kinetic energy. So simply gain in kinetic energy. Okay, so if it has no energy here, so simply kinetic energy. If it has some energy here, so then this is the gain in kinetic energy. So we can simply calculate, this is Q times delta V. So this will be equal to 1/2. If it's U is 0, so then you can find out mv square. So in this case I'm saying is that U is 0. So the change is equal to final kinetic energy. So we can simplify this one. If V we need to calculate, this is the speed. So that will be equal to Q times delta V multiplied by 2. This will be divided by M. and the root of this one, so we can find speed. So this is how we can calculate. We can also figure out actually by kinematic equations. We can also figure out by kinematic equations by here. Okay, but by conservation of energy, this is straightforward and you can save a lot of time. Now, there can be one more question about that. They can ask you, what is acceleration actually? Sometimes they can ask you to calculate acceleration if you place a positive charge here. So what is acceleration? So by second law, we simply understand it has to be F net, means the resultant force, or I can say F net divided by mass of the charge. So how we calculate F net in this case? So F net simply is the electric field E multiplied by small q, means the charge on this charged particle divided by the mass of particle. So this is how we can calculate. Sometimes E will not be given to you, so you have to figure out E by yourself. So if this information is given, delta V is given to you, and the distance between plates, for example, let's say this distance is equal to D, if this is given. So we can replace this one with this formula. I will write down here E is equal to delta V over D. So this formula you can write down then. This will be delta V Q over MD or DM. So this will be equal to this one. So this is also how we can calculate acceleration. But also we need to understand is that in this field, for example, as this field is a uniform field, so F net at any point has to be the same. F net has to be the same. If F net is the same, so this acceleration actually, this is uniform, or we can simply say this is constant acceleration. So also you need to understand this acceleration will be constant. So simply I will write down here for you, this will be constant. Okay, so these things we have to understand about electric field. Okay, I hope this is clear to you. If you have any questions now, you can ask me, otherwise I will go explain you more about electric field. Okay, for taking notes actually, you can watch this video after class and you can take notes. Okay, if no question until now, let's move on to next one. So I'll clean certain part of this and I will write down more points for you. Okay, just few minutes and okay. Okay, next thing please, we need to understand there are a lot of little small points we have to be very clear. Let me ask you one question now. Let's say we place one small charge here. So let's say we have charge. Okay, let's say we have this one small sphere. This is one small sphere. And let's say we have one big sphere now. This is one big sphere. Let's say the charge on this one, for example, let's say is equal to Q1. So we connect them with a wire. First of all, we connect them with a wire. Okay, this is a wire actually. We just connect these two spheres by a wire if we connect them. And this one, let's say, is big sphere. Charge on this one now, they are in electrostatic equilibrium, means no charge is flowing now between them. So the radius of this one, let's say, is equal to R, and this is a big sphere. Let's say the radius of this one is equal to 2r now. So we understand that charge will flow as long as there is a potential difference. If there is no potential difference between this one and this one, let's say if the potential here is V1 and potential here is V2. So when V1 is equal to V2, there will be no net flow of charge, means no current will flow. So when V1 is equal to V2. Okay, so this we understand simply. If no potential difference, no flow of charge. Okay, means no current will flow. Now the question is that how much charge is on Q1, how much charge is on Q2, which charge is greater, which charge is smaller. So let's try to figure out that one. So the V1 has to be equal to V2 because they are in equilibrium now, means there is no net flow of charge. So the V1 we can figure out that will be equal to KQ. Okay, so let's just figure out. Just little wait. So that will be KQ1 over R, for example, and this will be KQ2 over R2. So this one. Now this is R2, for example. We can replace this one. This is equal to 2R. So we can simply say this is equal to 2R. Okay. Now from here you need to understand as V1 is equal to V2. So you will simply say that the Q2, for example, so this has to be 2 actually. This has to be 2. You see, this has to be 2 times of that one. Or if I don't write this 2 here, still we can figure out. So one way is that you can figure out. This is not actually, so just wait here. So this Q we can cancel with this Q, and R you can cancel with R. So we will find out from here that Q2 is equal to 2 times of Q1. So this is one thing we will understand, we can derive from here. So the Q2, I will simply say this is equal to 2 times of Q1. It's 2 times actually, it's not 4 times. Okay, now this is one thing we have found. So Q2 is equal to 2 times of Q1. Now let's go to next one. Now how about charge density? So let's try to find out charge density. Charge density now find out. So what is charge density? Charge density, often we use this symbol, and this is equal to Q over surface area. So because we are talking about the sphere, so we are talking about sphere. So it means the surface area will be equal to 4 pi r square. Okay. Now we can find for 1, so we can find for Q1. So here surface charge density for Q1, and on this end we can find out for Q2, mean the surface charge density. So for this one we can find out for the first one. So you will simply say this is equal to Q over 4 pi r squared. So this is we can find out. I will say this is 1. And for the second charge, actually, we can find out for the second sphere. So this is Q, the charge on that one. That charge is equal to 2 times of Q1. So I'm writing this is Q1. So divided by, this is 4 pi r squared. So this is 2r. So we can square off this one. Now you can see from here. So if we multiply this one, so you will see that first of all we can cancel, so we can just do a little bit quicker. So you can see, so this 4r I can cancel with this 4r, and this q we can cancel with this q, and this r square we can cancel with this r square. So here we have 4 actually, and here we have 2. So if I say this is sigma 1, and this one will be sigma 1 by 2. So the surface charge density will be half. So you will say that the surface charge density will be half of that one. So this is one thing more you need to understand. Okay, so this one please. This has 2 times charge, but its charge density is half. Okay, so not no, it has double charge. It means its density is also double. No, its density is half. So you have to be very careful about this one. Sometimes they will ask you in multiple choice question like this. So you need to understand not only just simply, oh, Q is double, it means charge density is also double is not the case, because this is R square, so you have to be careful with this one. Okay, so let's try to calculate few more things about this setup, and then we move to another concept. So let me clean this part here. So okay, now next thing we need to calculate is electric field. Now which one has stronger electric field? So let's try to calculate electric field now. So the electric field, for example, if I need to calculate first of all for Q1, I will say its electric field, let's say, is E1. So the electric field we can calculate, E1 will be equal to K times Q1 over R square. So this is electric field for E1. And for second sphere electric field we will calculate, that will be K Q2 over R2 square. So we will simply say that this is K times, this is 2Q over, this is R2R square. So we have here. Now, if you look at this one and charge density, everything is the same actually. So it means this electric field, you will say, will be double than this electric field. Okay, so E1, for example, if we do this one, what you will get is that E2 will be equal to E1 by 2. It means E1 is double than E2. So the electric field is double, stronger, is 2 times stronger than E2. And the charge density, E1 is 2 times of charge density of sphere 2. And here this is a summary actually. The Q2 is equal to 2 times of Q1. So these two things are same. Why? We have a relationship for this one. We can also found electric field actually is equal to charge density divided by epsilon naught. So this is also important, you need to understand. So if the charge density is double, it means electric field is 2 times stronger. So if you just want, you are not very clear how we got this one, simply you can figure out from here. So we have density, charge density, this is equal to Q over 4 pi epsilon naught. This is 4 pi here, just let me clear this one. So this is 4 pi r square. So this is 4 pi r square, and we 1 over epsilon naught. Okay, so from here then if we simplify this one, so you will see that so this is what we will get. We often used to write like this. We say it is 1 over 4 pi epsilon naught. So this is 1 over 4 pi. So we can simply write down here 1 over 4 pi epsilon naught multiplied by 1 over r square, and here is Q. And this one we use, this is equal to K. So what we will get, that is equal to KQ over r square. So this is r square. So simply, so this is an other relationship which is very useful, and this is between electric field and charge density. So we need to be very clear about this one. So this is very important part actually. What I have written for you here, you will see in many papers, they will ask you about this one in different ways. So this is very important. So you have to keep this one in your mind. Okay. We have done a lot of review now and we have discussed a lot of points. So I will stop for a while so we can go to questions, we can try these concepts, then we go to next concept. So I will explain you some more points. So let's go and do some questions now so we can apply this knowledge. Okay, so these things you have to keep in your mind. Okay, here now. So you can see here now. So try this question now, read question carefully and try to answer. So try to figure out your own answer. Okay, so this is for uniform electric field. Total work done is asking you total work done. So another way to say this one is you need to calculate the electrical potential energy. So another way. So formula for this one we have Q times delta V. So you need to figure out how much is the charge here and what is the potential difference. So potential difference, if I move from here to here, so the potential difference between these 2 points. So you have to be clear about points. So we have 2 points here. So the potential difference between 2 points is 40 volt. So you can just multiply and you will get your answer. And the amount of Q is given to you, this charge. So this is just to confuse you. Don't worry about that one. Formula is quite straightforward. Q times delta V. Okay, if delta V is 0, for example, if I move my charge, for example, from here to this point, how much work do I need to do? If I move charge from here to here, okay, excellent. I think answer is this one. Excellent. So now you see, if I move charge from here, let's say this is point A to point B, work done has to be 0 because along this line there is no potential difference. So it doesn't matter I go like this, it doesn't matter I go like this. Okay, excellent, it has to be 0. Excellent. So it doesn't matter I go like this, any path I follow, if I go even like this, then come to this one, the work done will be the same because delta V is the same and Q is the same. So the answer will be this one, just multiply. So you have 40 and we have to multiply with this one. If I move charge from here to here, then you have to multiply by 20. So just you need to understand delta V between 2 points and then you can figure out work done. So this is how we can answer. I hope most of you are clear about this one. So let's move on to next now. So the answer should be E for this one. Excellent. So now let's try this question now. So take some time and try to answer. So the formula you will need for this question is, maybe some student didn't remember formula, so I will just write down formula for you to help you a little bit. So yeah. Okay, excellent. If you have got answer, I'm not clear if it is answer. It should be greater than 0.36. So this is not, you see here, this one you need to understand. Sometime in exam, we need to understand how to figure out answer quickly. So this one, if distance is this one, or if distance is this one, the force is this. Now, if the distance is shorter, force has to be greater. So it means this is not possible, this is not possible, and this is also not possible. So the answer is here between these two. So how we can figure out? So the best way to answer this one is, if you look at this formula, so this is one way we can cancel it is not possible, not possible. Then we can find out. Even sometime in exam, if you have short time, you can just look and you can answer without calculations. So, but if we do calculations, we can do like this. Now, we need to understand in this formula, for example, we need to understand two positive charges. So it means the next situation is like this. So the next situation is like this. So we have this distance. So let me just explain this one. So this distance is given to you. You see the charges are the same. This is Q1. This is also Q2. Is the same. This is also Q1 and this is Q2. Same charge. So in this formula, we need to find out what is same. So I will simply say this stuff is same. So I no need to worry about this one. So I will write down the formula that F1 D1 square is equal to constant. Okay, you see it's so simple now. So now we will say that F1 D1 square, for example, it also true for the other one, means it has to equal to F2 D2 square. Now what we need to find? We need to find F2. So simply F2 is equal to F1. F1 was given to you. So I will just write down the formula, then you can plug in values by yourself. So and you will get your answer. So F1 is here. F1 D1 square. So just plug in divided by D2 square. So the F1 you see is given, D1 is given. Just plug in and you will get your answer. So this will be the answer actually. So this is how we can answer. You can simplify and you can find the answer. Okay, so I hope this is clear to you. So if this is clear, we can move on to next one. So then you can find your answer. Okay, so let me check answer now. So answer is A. So this is by ratio we can find out. Okay, let's try this one now. I think you don't need calculation for this question, but it's conceptual question. So read this and try to answer. So read question carefully. Okay, let me highlight some points for you. First thing is net negative charge is given and charge is at rest. So which statement is true? So simply the best way is that okay, excellent. So here please, this is how you can draw. This is your negative charge now. So this is at rest now. So it means excellent. Answer is C, but this is straightforward question. So this is how you can answer. Now you see it's directed into into the rod. So this is directed into the rod. So this is how we can answer. Okay, excellent. If you got right answer, wonderful. So let's move on to next. So the answer should be C. So let's check answer here. Okay, this is then simply is asking you about electric field, direction of electric field. So these electric field lines are telling you is that if you place a positive charge here, the force on this one will be to the negative charge, that's all, or into the rod in this case, in this specific questions. Okay, so let's try next one now. Okay, so please read question and try to answer first by yourself. Okay, so you just need these formulae actually. This is conceptual question. I just write down these formula for you to just recap and understand this. Okay, so if you look back actually, as I explained to you previous actually, if you have one sphere and you have another big sphere, if we connect them together, if we connect them, let's say this one has, okay, it has to be, excellent, it has to be E actually. If we connect them, let's say this has a Q charge, so this charge will start, if this has zero charge at the beginning, when it was not connected, but when you will connect this one, this charge will start flowing from here to here until this V1 is equal to this V2. If this is 2, for example, if this is 1, so charge will flow until V1 is equal to V2 until there is a potential difference. So this is same potential means delta V is 0. So this is simply telling you delta V is equal to 0. So this is important, you need to understand. So that's the reason we apply a battery, for example, when we have a battery, we see current will start flowing. If no battery, no charge will flow, means there is no net flow of charges. So there must be a potential difference. Otherwise, charge will not flow. Okay, so this is the answer. Okay, let's try this one now. Okay, here please, now for this one you need to understand midway between two charges plus 3q and minus q are separated by a distance 2d. If the Coulomb's constant, so we have two charges, you can see here we have these two charges placed here, so you can say here, and is placed midway, so here you can find out, so this distance is equal to 2d, this distance will be d, and this distance also will be equal to d. Okay, so just 1 minute. So in this case, for example, you need to understand is that if this is a positive charge, so the force due to this one will be this way. So this is force due to plus 3q will be this way. It will apply force this way. But this is a negative charge. So for negative charge, also we understand this will also apply force this way. So the force due to minus negative also will be this way. So now what you need to do is the total force on this one will be equal to force due to this plus force to this. So then you can calculate. So this will be k times 3q over. So this is the force. So don't worry about negative signs now, because direction is same. So the force is in the same direction. So then you can multiply. So this is d square, here you have a q, and plus total force, this will be k, and you have q, this is q over d square, and you can add and you will get your answer. Okay, so this is how you can figure out this now. Simply, this is thing you need to understand. You have to add the force because the force is in the same direction. So this is what we need to understand. Okay, so this is our answer. So if you add, you will get your answer. Okay, this is how we can figure out. Okay, so here. Okay, so try to answer this one now. Okay, so in this case, we are no need to worry about direction actually. So let's say this is negative plate. I place this minus 24 millicoulomb here now. Okay, E, excellent. So the work done simply is equal to Q times delta V. Q times delta V. Now delta V is not given to us, so we can little bit modify this formula. So we understand that E is equal to delta V over D. So delta V is equal to E times D. So we can say this is Q E D. So now you can see here the Q is here. This is given to you, and D is given here, and E is given here. So we just need to multiply. If you multiply, you will get your answer. Okay, just multiply. If you will get this answer. That's right. This is, you see here, sometimes I no need to do calculation. I can look at these numbers. So these are not possible. These are very small numbers. So this is okay. So in exam, you need to look at this one like that. Then you can find the answer. No, if you start calculating, maybe it will consume a lot of time. So this is one way you can quickly figure out. Okay, so this is our answer. Okay, now different type of question for you. So try to answer this one. This is conceptual question. You don't need any calculations. Okay, so what is our answer? Answer is not only B, is asking you region 2 has the same, this one you see, region 2. Okay, so it you can, okay, excellent. Okay, this one please. The question is asking you. Let me explain to you question now. One student has got, I think, right answer. So let me explain to you question now. Little bit explain question, and then I will show you the answer and answer. First of all, let me explain you question. So the question is asking you is that if you have a charged rod, this rod, I just draw positive actually. It can be positive, it can be negative. It doesn't matter. So I just draw positive. Positive. If this rod is positive and this is a conducting sphere, means a metal, so it means that electrons can move easily inside this one. So when you bring a positive charge, so this side become more negative, because this will attract negative. So more electron will stay on this side, or simply we can call that, say that this side will be more negative, so the opposite will be more positive. So the same is true for this one. It also have no net charge at the beginning, so the more charge electrons will stay on this side, so this side will be more negative. So you see, this is more negative, this is more negative. So this is one thing we understand. Now the question was asking you, region 2 has the same polarity as region. Same polarity means that if it is negatively charged, so which side is negatively charged? If this is positively charged, which side is positively charged? This is what question is asking you. So we use positive charge here, so this will be negative. So which side of this one is negative? So this is negative. So the answer should be B for this one. Okay, now if we bring negative, result will be the same. So if let's say this is negative now, so let's say this become we have negative rod now, because it was not given to you the rod is positive, rod is negative. So because question is based on that. Now let's say if this rod is negative now, so electron, they will repel electron from here. So more electron, they will leave this side. So they will sit away from electron. So this side will be more positive. So this is more positive. Same will happen here. So this side will be more positive. So electron will stay here. Now if this is positive, which other region has also net positive charge? So this has net positive. So this is what question was asking you. The same polarity means the same net charge as here. So on this side, this is net charge. This side is also. So they are the same. So it means it has to be B. So is this clear now? Okay, so is this one is clear? So we can move on to next one if this is clear now. Is asking same polarity means net charge, the same net charge. Here, same here. Okay, so now I will go to next topic now. There are a few more questions, but there are a lot of questions given in topic-wise questions. So you can practice from there. Now let's move on to next topic. Okay, in notes, these are given to you. So you can do more question about this topic. Now let me explain to you the next topic. So I will move on to next topic now. So is this is clear? Okay, so the answer is B. Okay, so these questions these are given in your notes actually, so you can practice from there. So let's go to capacitance now. So capacitance is a new topic we need to understand. Okay, so for capacitance. Okay, here please. First of all, for capacitor, there are few things you have to be very clear about that. If we have two plates, let's say we have these two plates and we have one switch here, and let's say we have also one resistor here. I attach one resistor and now we connect this one with a battery. So you can see here, if we connect with a battery now, if we connect with a battery, now what will happen is that as soon as we close this switch, so the electrons from this plate, first of all, you need to understand the basic thing you need to understand is that if I have two plates actually, there is no net charge on these two plates. There is no net charge. So when no net charge, when we talk about this one, no net charge, it simply means that it has same number of protons, same number of electrons, so there is no net charge on this one. As soon as we close this one, so this side means electron will leave this plate and they will be attracted towards positive terminal, and from here negative electrons means the charge will go on this plate. So with time what we will see is that this plate become more positive, it is connected with positive plate, and this side become more negative. So what we did in this case, actually, if you look at the big picture of this one, what happened in this case is that only charge separation. What we did is that we just separated charge. So this is only charge separation. Battery is not giving more electrons, or there is no any net charge. Plus Q you have here, you have minus Q here. The amount of charge on this one is equal to amount of charge here. So what happened is that in this case we store energy. So the capacitor is used to store energy. So in this case what we did, by separating charges, we have stored energy on these plates in electric field. So this is what happens. So this is R. So at the beginning, at t is equal to 0, when the t is equal to 0, or you just close the switch. Just close a switch closed. I will simply say when you just close switch, when switch closed at the beginning, when you just close this switch, what will happen is that charge will start flowing actually. So at this point, if you need to calculate I, what is value of I? So let's say this battery is voltage is V. So I you will calculate at the beginning, that will be equal to V over R, as you will say there is a no any capacitor here. So we will simply say when it is not charged, when capacitor is not charged, so it is just acting as a wire. Simply I will say that it is just acting like a wire. But as it will more and more charge will be stored on this one, so finally it will stop. There will be no current. So how we can understand that one? What it means is that, let's say this is voltage of the battery, and let's say the voltage across these plates, let's say, is equal to Vc. C means the voltage of capacitor. At any time, VB has to be equal to Vc plus VR. Okay, Vc plus VR. So with time, as the time is passing actually, as the time is passing, what is happening is that this is not changing. Voltage of the battery is not changing, but the voltage of this resistor will go down and voltage of the capacitor will go up. And finally, what we will have this will be VB, and this will be equal to Vc when capacitor is fully charged. So when capacitor is fully charged, I will simply say when capacitor is fully charged, at that time VB will be equal to Vc, means the EMF of the battery will be equal to voltage across these two plates. So we will say VR will decrease, Vc will increase. If you calculate at time t is equal to 0, of course this doesn't make any sense, but t0 means that when you just close the switch, just switch is closed. If you look at this point, just switch is closed. If we look at that point, so we will simply say at that moment VB is equal to Vc again and is equal to VR. But at that moment, this will be 0. And at that point, VB will be equal to VR. Okay, so this will be true. Later I will also show you the animation actually. Let me explain you a little bit. Then I will go to animation. I will explain you from animation. So first I want you to have a little bit understanding of this. Now this is how we can calculate. Now the next thing we need to understand is that we have studied about resistors in series and resistors in parallel. So how about capacitors in series? For example, when you connect capacitors in series, so here I will write down when we connect capacitors in series, and here I will write down when we connect capacitors in parallel. So we need to understand, because we will discuss later RC circuit. RC circuit means resistors and capacitors. They are in the same circuit, as you can see here. This is an example of RC circuit. Means you have a resistor and you have a capacitor in the same circuit. So RC circuit we will discuss in detail. Maybe not today, we don't have enough time, but next class I will explain. So capacitors in series and capacitors in parallel. So if we have this power supply here, and we have, let's say, one capacitor here, and I'm not drawing any resistor here to make it simple. So, and we have another capacitor here. So let's say this capacitor is C1 and this capacitor is C2. So I'm just talking about capacitors only here. So how about the total capacitance? So how we calculate? So if this side of the battery, it is positive, this is a positive terminal of the battery. So you will simply say that, if this is positive, as I explained to you here, this side also be positive, because electrons will move from here to positive terminal. So electron will move from here, lack of electron. So here, so this side here will be positive, because this will go, electron go from here. Now then electron will stay here. Now if this side is positive, how about this one? This you will simply say it has to be negative. And these electrons will come from this one, because when these electrons will come, electron from this plate will be repelled and these electrons will stay on C1. So this will be positive. This will be positive. Now you can see from here is that in this case Q is the same. Q on C1 will be equal to Q on C2, because this charge is just induced. When electrons come here, they repel electron from here. If you want to see little more clear, I can say here at the beginning there were electron here. As these electrons came, they repel these electrons, so they move to next place. So now here are no electron, it means here. So these electrons move to next one. So here now what we have only positive, net positive charge. There are electrons, but we are saying net positive charge. So the Q is the same. Means the Q on C1 is equal to Q on C2. Other way you can also say Q1 in this case is equal to Q2. Okay, now if this is voltage V, so this voltage has to be V1 and this one has to be V2. So we will say V of the battery means the potential difference across battery, or you can say EMF of the battery. This is ideal battery, it has no internal resistance, so the V has to be equal to V1 plus V2. Now how we calculate capacitance, the relationship between Q. Now we need to understand what is relation between Q, V and C. So that relationship is, we can calculate Q is equal to CV. Here it is. So Q is equal to CV. Now the V, for example, here we have. Now if we need to calculate C, so we can rearrange this formula and we can calculate. So we can replace these two capacitors with one capacitor. So we can replace with one capacitor. So we can write down the C from here. This will be equal to Q over V. So the C will be equal to Q over V. So the C is equal to Q over V. So if we rearrange from here, so from this formula we can rearrange and then we can calculate. So now V, for example, here, so V is equal to, if you want to write down V, so V will be equal to Q over C. So I can replace this one with Q over C. This is the total capacitance, and here you can find this is Q1 over C1, and this will be equal to Q2 over C2. So you will get 1 over C is equal to 1 over C1 plus 1 over C2. So this is a formula. This is just similar to resistors in parallel. So here is just opposite. So 1 over C means the C equivalent is equal to 1 over C1 plus 1 over C2. And if we repeat the same process for capacitors in parallel, so we can have two capacitors like this. They are connected in parallel, so we can also derive the formula. For this one, I will just write down the formula. I will just explain a little bit, and then I will just write the exact formula, final one. So let's say this is C1, its capacitance, this capacitance is C2, and let's say this voltage is V. Now, in this case, imagine this one. Look at this. These are two capacitors now. We connect them like this here. You see, if I bring them together, I can connect them like this. This become one big capacitor. Simply, you have two capacitors, they are in parallel, you combine them. So you get one big capacitor here. So what it means is that if we look at this one, so simply this one is telling us that the V in this case has to be the same. So see, voltage across this one has to be the same as this, So V is equal to V1, and this also has to be equal to V2. So we can rearrange formula. Q is equal to CV, and we will get actually in that case. In this case, you will say that Q has to be equal to Q1 plus Q2, the charge. Or simply, if you rearrange, you will get C is equal to C1 and plus C2. Okay, so this is what we will get. This is just opposite to resistors actually. So this is just opposite to resistors. When resistors are in series, it means capacitors are like in parallel. So this is also true when the capacitors are in parallel is similar to resistors are in series. So this is how you can remember this one. Okay, so this is how you can remember. Now, one last thing, then we will stop over class. For example, if we have two capacitors, for example, let's say we have two capacitors. So here, let's say we have two capacitors. We connect them first of all in series. Just last thing, then class will be over. Just let me explain one thing. I just want to talk about energy store on capacitor. Let's say we have here, let's say this is equal to 12-volt battery, and we have one capacitor here. Let's say this is 3 microfarad, and this one okay, let me just use the big number for simplicity. This is 3, and let's say this one is equal to C2, this is equal to 6. This is equal to 6 farad. It's a big number, but just for sake of calculations, I'm just going to make it simple. Here, now we have another setup here. Let's say we have two capacitors. These are two capacitors here. So this is battery, and we can attach an other capacitors here. So we have C1 and we have C2. Let's say this is also 12 volt, and this one again I will say this is equal to 3 farad. Farad is a unit of capacitance, so the unit of capacitance farad. So unit of capacitance for a student who didn't study this one, so you need to understand the unit of capacitance is farad. Farad, and we use capital F for this one. So this is equal to 6 farad. Now, which capacitor will store more energy? So first thing you need to, okay, so which one? So which setup will store more energy? Is it in series or is it in parallel. So which one will store more energy? Is it when you connect your capacitors in series or when you connect your capacitors in parallel? So you have two options. So one is series. If you want more energy to be stored on your capacitors, how you will connect them? It has to be in series or it has to be in parallel. So now you will answer this question without calculations, but next class we will do calculations. Okay, so you can just answer this one based on capacitance. Excellent. So you can answer simply this one now based on capacitance. If they are, in this case, for example, what is the C equivalent? Total capacitance. So if you multiply these two, so and divide by sum of them, I think you will get 2 farad. So this is the capacitance. And if you, this one, if we calculate, so in this case, we will get the C total will be equal to 9 farad. So this is 9 farad. Okay, so more capacitance, same voltage. So it means that if this formula, you see the beauty of this formula. So this is telling you Q is equal to CV. If this one is the same and C we increase, it means that capacitor will store more energy if V is the same. So this one will store more energy. So if we want to connect capacitors in a way we want them to store more energy, we need to connect in parallel. So next class we will do calculations and also do more questions about RC circuit, and then we will move to magnetism. Okay, so that's all for today, and I hope now you have studied a little bit more about electricity. Okay, so that's all for this class, and see you on next Monday.